Good morning, fellow programmers. Thanks for joining me. I'm T-Pain. And welcome to Let's Learn C++. Feel free to use the skip ahead feature on the right-hand side to jump to any specific sections or examples. Make sure to have annotations turned on so you can see the updates I make to these videos. I'll be using Visual Studio Community Edition, which you can download from visualstudio.com. However, you can use or follow along with whichever application or IDE that you like. Today's focus will be on arrays, characters, and strings, which builds on previous lessons, so check those out if you're unfamiliar with a topic. If this is your first programming language, I'd strongly recommend checking out my Let's Learn Python series, which teaches you the fundamentals of programming. All you need are the Basics and Object-Oriented Programming series, linked to the right, and you'll be well prepared for this C++ series. Alright, so what is an array? An array is a spectrum of light unseen by the human eye. It's made of magical unicorn hair that's moving faster than the speed of smell. And arrays are all around you, protecting you from unknown danger. Okay, that's silly. We all know that unicorns don't have hair. An array is a series of elements of the same data type. In Python, we use lists, but lists were able to mix and match different data types. A single list in Python could contain strings, ints, and booleans. C++ also has lists, but we won't cover that for a while, and lists are not one of C++'s default types. So arrays are the next closest thing. Arrays hold a series of elements of the same type, and we must declare how big the array is when we create it. So how do we create an array? First, we declare the type and name just like a regular variable. After that, we have square brackets, which may or may not contain the size of the array. I'll explain in just a bit. Then we may or may not have an equal sign. Finally, we may or may not set the default values of the array using curly braces. Values in curly braces are assigned to spot 0 and upward. So let's go ahead and punch out some code. So here we have our default code that we've been running for the past few lessons. At the top we have include IOStream. Then we have include string using namespace standard, the main function right here, a return at the end, and then right before the end we actually have the string y and then get line y, so that when we run the program it doesn't automatically close out. We don't have to set a breakpoint or something to see the results of our program. Instead, it'll wait for us to press enter and then it closes. So we're going to begin our code by declaring an array with int my underscore array and then open close brackets 2 within it, and then in that with a semicolon. So again, it's declared just like a regular variable, except we have the square brackets to the right of the variable name. And then right here is the size of the array, which we've set to 2. Next, we're going to assign some values within the array. And this is just like in Python, where we're just going to call the variable name myArray and set the very first value equal to 0. Then we're going to go ahead and copy this line, paste it down below, and replace both the zeros with ones. And there you go. That's as simple as it gets for assigning values to an array, just like in Python. The only thing that's different is this semicolon at the end. So what was that I was saying about the equal sign and curly braces? Well, we can actually create an array with another method. And we're going to type int my underscore array 2, and we're going to set that with a size of 3. And then after that, we're going to type equal sign and then set some curly braces that contain 0, 1, 2. And then end that with a semicolon. So this is the way that you fill out an array if you so desire. So we've successfully set up the initialized values for the array. After that, I want to show you something else we can do. Let's copy and paste this line right here and paste it down below. And what we're going to do is we're going to delete the equal sign, replace this myArray2 with 3. So it's now myArray3. We're going to leave the size value in there of 3. That's fine. And we're just going to place a 4 in the curly brackets. Now, will this work? If we actually run our code and run it, it'll compile everything correctly and we're good. No errors or anything. So what's going on? What's up with this equal sign? I mean, we had it in the previous line. Do we not have to keep it in every line? Actually, no. You don't need to declare it when you're declaring the values within the array. So let's paste that line again. This time we're going to name this myArray4, and we're going to set the size equal to nothing. We're actually going to leave that blank. Then we're also going to delete that equal sign, and we're just going to put in a whole bunch of more random values. We're just going to put in 7, 7, 7 within the curly braces. And notice no error again. So we don't need to have the equal sign. We don't need to have a value within here for the size of the array. Instead, it's going to figure it out based off the values that we pass inside the curly brackets. Very cool. Finally, I'm going to show you the shortest way to create an array. Now, we're just going to paste in that code one more time. This time, we're going to call this myArray5. Then I'm going to set the size equal to 4. We're going to delete the equal sign, and we're going to delete everything within the curly braces. Now, what does this do? Well, let's go ahead and find out by typing cout my_array5 and then indel, and then run it. See what it gives us. Oh, and we're going to include passing in some square brackets with 0 as the center value to grab the very first value of the array. And now it's going to output 0. Cool. So we've successfully set the entire array equal to 0 by just typing these curly brackets after the declaration of the array. What if we hadn't actually done that? What's going to be the value of this third array where we didn't declare the second and third value? Let's go ahead and type those in. So that's going to be 3, and then we're just going to pass a value of 2 in to look at the second index. We didn't define what was in those other values. We didn't pass them in, so what were they defaulted as? Well, they're going to be defaulted to 0 just like the other one is. If you pass in not enough arguments, it'll set everything to 0. So let's go ahead and run the code. And indeed, that third array has a default value of 0 set to its second item. Cool. So we're able to initialize a series of values for an array. Can we reset them all the same way? Let's go ahead and copy line 4, paste that down below. We're going to delete the int at the beginning. We're going to delete the braces here, and we're just going to place an equal sign in the middle. So now we get an error, and it's saying it can't do it. And even if you added the square brackets here, it still can't do it. Once an array is initialized, you can only access individual items of the array. I really want to emphasize that because it's slightly weird in that you can set up a series of values when you initially create it, but then when you have to go back and adjust it, then it's only one item at a time. So this is where loops are going to come in very useful. We'll cover loops and stuff though in a later tutorial. For now, know that you just cannot do this easily. So we'll go ahead and delete that out. Also, some other weird subtleties is that you cannot set an array to have a default size of 0. However, you can set it to a size of 1. Why you'd want an array the size of 0 or size of 1, I don't know. All right. So what's going on underneath the hood of this? Well, arrays are grabbing chunks of memory at a time because arrays are essentially individual variables next to each other in your memory. The best metaphor I can give to creating arrays is like going to a restaurant. You arrive with 4 people and you can get a table for 4. Works just fine. That would be if we created an array with the size of 4 and then we set the values for each of those. You can also go to a restaurant and show up with 3 people and still get a table for 5 because the others may be coming later. You can also call the restaurant ahead of time and reserve a table for 5 people that you know are coming. However, with the restaurant metaphor, you cannot change your table size. Once you get that table set, it is set in stone. This restaurant is extremely busy. Arrays cannot change size. They are set to be 5 or 3 or whatever you set their array size to be. It is set in stone. And the only way to get around that is to use a different data structure like vectors, which we will cover in a later tutorial. But for now, know that arrays are very restrictive. All right, so we've created an array. In Python, we were able to create lists within lists. Can you do that within C++? Absolutely. You can create 2D arrays. This is essentially arrays within arrays. And you can think of that as a spreadsheet where you have rows and columns. They take up the same amount of space as creating a single long array. All right, so how do we create a 2D array? Well, I'm going to start out by commenting out this code right here by pressing Control-C, okay, minimizing that. And then in here, we're going to type int array underscore 2D. And then we're going to create some in square brackets a value of 2. And then another set of square brackets with 3. So the first one is our rows, the second one is our columns for this 2D array. And if we want to access individual members of that, then just like within Python, we can type the variable name, array2d, and then pass in the location of the first one, which would be our row. We're going to say row 0, and then after that, we're going to declare which column we want to access, which is going to be 0 as well. And then we're going to set that equal to 1. And there we go. We're done. We're going to copy that line and paste it again down below and then just tweak the numbers out so we're accessing row 1 and column 2. And there we go. And we can change the assigned value to 6, and that is our array. And that is it. That's all it takes to create and access members of a 2D array. The same rules apply to creating a 2D array as to creating a 1D array. And you can create as many dimensions as you want in arrays. You can have it go 2, 3, 4, 10, 20 dimensions in, but it's very difficult to manage, and there are better ways to organize your data. I can almost guarantee it, and we'll cover those ways when we start delving into data structures. Alright, so we've dealt with 2D arrays. What other kinds of arrays are there? Well, there are character arrays. So let's go ahead and comment this chunk of code out right here. That's Control-K-C, and we'll shrink it down. Okay, and between these two common blocks, I'm going to add in some space. So what are character arrays? Character arrays allow us to create words, sentences in the traditional or old style of C. They were strings in the original C programming language and would allow you to do stuff like sentences and whatnot. The way you create them is pretty much just like you'd guess it would be. So we're going to go ahead and type char a, open and close brackets, is equal to, and then double quotes, ASDF, and then end that with a semicolon. And that's it. That's how you create a character array. You declare the array type, the variable name, put 2 brackets so to signal that it's going to be an array that you're creating, and then set it equal to whatever value you want. Now, one of the benefits of character arrays is that you don't actually have to define every individual element within curly braces. Instead, you can pass it in within double quotes, and that's significant, double quotes, not single quotes, to say it's a string of characters or a continuous array of characters that it'll input. All right, cool. So we've successfully created a character array. Now, there is a slight nuance to this that I want to show you. I'm going to copy this line right here and paste it below. We're going to replace this A variable name with B. And now we're going to do something kind of strange. I'm going to punch in the size of the array here within these square brackets as 4. Now watch what happens. There's a red underline here saying it's a compiling error, and the error says a value type of const char 5 must be used to initialize the char type 4. So what's going on is at the end of every character array, there needs to be a special character called a null character. It is recognized by \0. It is its own character too. So if we punch in 5 here, it will automatically punch it in to the end of it. C and C++ both tack on that character invisibly in the background. So that's why we set it to a size of 5 instead of 4. Because although we have just 4 characters in here, there needs to be room for that one last extra character. Cool. Is there any other ways we can create character arrays? Oh yes, there is. Thanks for asking. So we're going to go ahead and type char and then C, open close square brackets, equals to, or actually, we're not even going to set an equal sign. Instead, we're going to just use curly braces. Okay. And then we're going to put in the curly braces A and B as individual characters enclosed in single quotation marks. And now I want to test out what each of these are doing. So I'm going to go ahead and type out C out A indel. Copy, paste that line a few times, and we're going to replace those with the appropriate variable names. Save, save, save. All right, and run it and see what the output is. Now, something very interesting is happening here. First one, A, outputs ASDF just as we'd expect. B, same thing, works just fine. Then C happens, and something strange happens here. So we have A and B being output, but then after A and B, we have a whole bunch of these weird characters followed by ASDF. So somewhere in memory, we have reserved this third variable, and we have a whole bunch of garbage in between, and it's actually going back to an older variable, could be A or B, in memory, and then it finally hits that null character. So because we did not explicitly state that null character, it is giving out a whole bunch of garbage values because it's going to basically be continuing to output what's in memory until it hits that null character. Very interesting. So let's go ahead and press enter to exit out. And the way we fix that is we just add it in by single quotes, \0, single quotes. There you go. That's the null character. And now it will be very satisfied. It'll be a happy baby. And there we go. We have ASDF, ASDF all working correctly, then A and B working correctly, and it's good. Cool. Is there any nuances to this null character? Copy, paste this line down below. We're going to replace the C with D. And now what I'm going to type is an extra few characters. We're going to type, let's just type C after that. And then we're going to add in the null character right here at the very end. So we have A, B, null, C, null. What do you think would happen? Based on what we saw with the error in when we output C, it keeps going until it hits the null character. What do you think is going to happen if we have it in the middle? So let's go ahead and create an output line for line D, for variable D. All right, and save that and run it. And as we predicted, it does A, B output correctly, and then it hits the null character, does not output C because, again, once that null character is hit, it'll stop outputting altogether. So it's done. So we've covered one of the many special characters in C++ that comes with it, and that's the null character. What other special characters do we have? There is also, just like in Python, a \n for a new line, \t for a tab character. There's a \v for a vertical tab character, \b for a backspace, \r for a return character, a carriage return, double backslash, which is just allowing us to input a backslash question mark, so that allows us to put a question mark, and then backslash single quote or double quote. Now what about strings? Why haven't we been using strings? Well, strings are much bigger. So let's go ahead and comment these lines of code right here. Control K, C. All right, so I've entered in a few more lines, and we're just going to type out cout and then size of string and then size of the char to compare the two sizes of them. Now remember, this is in bytes. This is not bits, bytes. These are dramatically different in size, which is one of the biggest reasons that if you're looking to conserve memory or conserve space or reduce the amount of processing that you need to do or something, then character arrays may make the difference that you're looking for. Versus strings, strings have a lot of built-in functionality. All right, so let's enter to exit the program there, and let's uncomment this last block of code I've kept hidden from you for so long. So we're going to go Control KU, uncomment that. And then here I have a string that's created that's called ham, and the second one called sandwich. And then after that, we're going to access one of the string's basic functions that are built right into it. We have the variable ham, and then we call the function called swap. And then we pass in the second variable we want it to swap with. So this is essentially to swap one string for another back and forth without having to create an additional temporary variable to store it as they swap back and forth. Cool. So when we output this, this means that our variables ham and sandwich will actually be reversed here. So we're going to have sandwich output first and then ham. Then we call this function here called size. Size will output the amount of characters within the string. And then here, ham.find, we're going to be searching for the letter A and trying to find that. It's going to output the location in an integer value of the first instance of A in ham. After that, we're going to access the first item of the string by using the same accessing method for a character array. We're just going to be passing in the square brackets and then the location that we want to access with the 1. In this case, it should give us an A because both ham and sandwich have the second letter as A. Finally, we're going to perform two quick operations of showing you that the strings can be added together just like a math function, in that they can be combined using the plus symbol. And you can also combine them using the plus equal symbol. And finally, we're just going to output sandwich to show you the results of combining it with ham. So let's go ahead and save that and run it. And here are the results. So at the top, we have 21 and 8 being the size of these guys. Then after that, we have sandwich and ham being output. They are now reversed because that swap function we called earlier. Then we have size of ham, which is now sandwich, is going to be 8, so that's 8 characters long. That's what we see right here. Perfect. Then we have find A, and it returns 1. So 1 being as how the index is starting at 0, it is the second item. So that makes sense because sandwich and ham both have A as the second letter. So this is the second item essentially, even though it's 1. Then we access the second item of ham, the string, and it's an A, of course. And then finally, we combined sandwich and ham into a single variable, right here, sandwich, which now reads as ham sandwich. Perfect. References for these and more can be found at c++.com/reference/string/string. All right. Thank you so much for watching. Great job keeping up. Definitely try these coding challenges shown here and the debug challenges and more linked below in the description. You are a brilliant programmer, and I'm sure you can do it if you set your mind to it. I will be posting solutions for all these problems after a group of tutorials, but I really want you to develop your own skills and solutions. There's often many correct answers. Please leave me a comment below if this helped you at all, and also check out the comments if you're having problems. Lastly, please do me a huge favor and subscribe to my channel. It would really mean a lot to me. Hit that likey like button to show some love. Come on, hit it. Hit that like button. You know you want to. Thank you so much for the support, and keep the dream alive.